Dear children, welcome to 10th Standard Physics. Tenth Standard Physics. There are 10 chapters in 10th Standard Physics. They are electromagnetic induction, electromagnetic radiation, electronics, circular motion, gravitation, rockets and artificial satellites, heat, light, sound, and the universe. Let us study Chapter 4, Circular Motion. The current learning points in this chapter are Introduction to Circular Motion, Concept of Circular Motion, Centripetal Force, Centrifugal Force, Illustrations of Centripetal Force, and Illustrations of Centrifugal Force. Capsule 1. In this capsule, you are going to study Introduction to Circular Motion, Concept of Circular Motion, Centripetal Force, and Centrifugal Force. Motion. Dear children, you come across many kinds of motions like motion in a straight line, oscillatory motion of a pendulum, or a seesaw motion. So, let's recall what is motion. First, let us define motion. When a body is continuously changing its position with respect to the surroundings, then we say that the body is in motion. Any kind of motion is governed by Newton's laws. They are Newton's first law of motion. Every body continues to be in a state of rest or of uniform motion along a straight line unless acted upon by an external force to act otherwise. It is also called the law of inertia. Inertia of rest. Let us understand the concept of inertia of rest. Consider a glass. Place a cardboard on it. Now keep a coin on the cardboard. Observe that the glass, cardboard, and the coin are at rest. When the cardboard is moved away from the glass, the coin falls vertically downwards due to gravity. Here, coin did not move along with the cardboard because due to inertial property of the coin. It would try to remain at rest, but when the cardboard was moved away, force of gravity changed the state of rest. Inertia of motion. Dear children, the passengers in the bus are in motion along with the bus. When the bus suddenly comes to a halt, the passengers tend to move forward. This is because of inertia of motion. That is, when the bus comes to halt, the passengers tend to continue their state of motion in the forward direction. Newton's second law of motion states that acceleration depends on the net force acting on the object and on the object's mass. That is, F is equal to ma. Dear children, the simple way to understand this is greater the heavier objects require greater force to change their state of rest or of motion. Newton's third law of motion. For every action, there is an equal and opposite reaction. Consider the movement of a rocket. When the hot gases move downwards, the rocket moves upwards. This makes an action and reaction pair. Dear children, pair up and define the following terms. A. Velocity. B. Acceleration. Remember, these are the physical quantities used to measure motion of objects. Answer: velocity. Velocity is the rate of change of displacement. SI units is meters per second. Acceleration. Acceleration is the rate of change of velocity. SI units is meters per second square. Now consider a car moving in a straight line. According to Newton's first law, net forces acting on it is zero. When a force is applied at an angle, it takes curved path. This is circular motion. Circular motion. Motion along a curved path is circular motion. Children, note down this important definition in your notebook. Here are some examples for circular motion. Car taking a turn or train moving on a curved path. Now let us understand about uniform circular motion. Motion along a circular path with constant speed is called uniform circular motion. Write down this important definition in your book. Here are some examples. Merry-go-round, giant wheel, motion of the earth around the sun, and many more. Dear children, it is time to think and answer. The velocity of an object moving in a circle at a constant speed changes because option 1, the object is slowing down. Option 2, the object is going faster. Option 3, the object is going slower then faster. And option 4, the direction is always changing. The correct answer is option 4. The direction is always changing. Now let us understand uniform circular motion in detail. Circular motion. Consider a body moving in a circular path. There is continuous change in direction. There must be an acceleration which is perpendicular to the path that is directed towards the center. This is called centripetal acceleration or radial acceleration. The force causing this is called centripetal force. Dear children, think and answer. An object is moving in a circle at a constant speed. Which one of these statements is correct? Statement 1. The velocity is also constant. Statement 2. The direction is constant. Statement 3. The velocity is changing all the time. And statement 4. There is no direction in this movement. The correct answer is statement 3. The velocity is changing all the time. Now, let us define centripetal force. Centripetal force is defined as the radial force directed towards the center acting on a body in circular motion. Children, write down this definition in your notebook. Centripetal force. The centripetal force can be provided by many different things. When a stone is whirled around using a rope, the tension of the rope provides centripetal force. For a car moving along a curved path, friction between tires and road provides centripetal force. For movement of celestial objects in space, gravity provides centripetal force. Dear children, think and answer. A satellite always stays in its orbit. This is because option 1. There is no gravity. Option 2. The satellite is being held there by centrifugal force. Option 3. Gravity is acting as a centripetal force. And option 4. It is being attracted by the gravity of other objects in space. The correct answer is option 3. Gravity is acting as a centripetal force. Now, pair up with your friend and answer. Which one is correct about the centripetal force? Option 1. It is opposite to the direction of velocity. Option 2. It is perpendicular to velocity and away from the center of the circle. Option 3. It is perpendicular to velocity and towards the center of the circle. Option 4. It is along the direction of motion. The correct answer is option 3. It is perpendicular to velocity and towards the center of the circle. Now, let us understand centripetal force by taking an example. The centripetal force can be measured using a formula. Formula for centripetal force. The centripetal force is given by F is equal to mv square by r, where m is the mass of a body moving with a constant speed v along a radius r. Now pair up with your friend and answer. Which are the physical quantities on which centripetal force depends? Answer: mass of the body in circular path, velocity, and radius of the circle are the physical quantities on which centripetal force depends. Consider a stone set to move in circular motion. At any point, say A, the centripetal acceleration is towards the center perpendicular to its velocity. Here, there is a reaction opposite to centripetal force called centripetal reaction. These two constitute action and reaction pair. Action is on the stone and reaction is in the opposite direction. Now, let us define centripetal reaction. Centripetal reaction is a reaction that is equal and opposite of centripetal force and is directed away from the center of the circular path. Children, write down this definition in your notebook. Now, let us see what happens when centripetal force is withdrawn. Stone tied to a string is whirled to give circular motion. Suppose the string snaps, that is, the centripetal force is removed. The body continues to move in the direction of its velocity as per Newton's first law of motion. The body moves in tangential direction, that is, perpendicular to centripetal acceleration. Further, there is a misconception that there is centrifugal force acting opposite to centripetal force. This is wrong. If there was centripetal force, the stone in this example would have moved in the direction opposite to centripetal force. But no, it moves in tangential to centripetal force. Dear children, think and answer. A model aeroplane held with a thread moves in circular path. Then the thread cuts. What direction will it fly in? Your options are 1. Directly to the center of the circle. 2. Directly away from the center of the circle. 3. In a circular path as before. 4. In a straight line at a tangent. The correct answer is option 4, in a straight line at a tangent. Now, let us understand uniform circular motion in detail. Example for centrifugal reaction. Dear children, you might have observed how blunt knives are sharpened. The sparks due to friction and the rotating wheel move tangentially out of the wheel. Virtual image or pseudo image. Dear children, you see the image of apple in the mirror as long as the apple is in front of it. That image of apple cannot exist on its own, that is, it is a pseudo or virtual or false image. Similarly, centrifugal force is a pseudo force. It exists only in the context of centripetal force. Further, you can experience this pseudo force while moving in a car. When car takes a turn, you feel as though you are pushed. This is again due to inertia. You tend to continue in straight path, but the car has begun to follow curved path. To make you go in curved path, the back of the seat or the door of the car exerts force. Kindly note these points in your book. Centrifugal force cannot be created. It is experienced in the context of circular motion. Hence, centrifugal force is due to the inertia of rotational motion. Centrifugal reaction and centripetal force form an action and reaction pair, but not centrifugal force and centripetal force. Dear children, pair up with your friend and answer. The forces involved in circular motion are: option 1 centripetal, option 2 centrifugal, option 3 both centripetal and centrifugal. The correct answer is option 3, both centripetal and centrifugal forces. Which one of these statements is correct about centrifugal force? Statement 1. It is a force acting away from the center of the circular path. Statement 2. It acts in the same direction as the velocity. Statement 3. It is a force acting towards the middle of the circular path. Statement 4. It does not exist. The correct answer is statement 4. It does not exist. Dear children, in the next capsule, we will study illustrations of centripetal force and illustrations of centrifugal force.